Hi, this is Mrs. Basden, and in this section, section 3.4, we're going to talk about moles. So if you remember from before, 1 mole is equal to 6.02 times 10 to the 23 of that particular substance. So that number is known as Avogadro's number, and it's just a chemical quantity that we use in chemistry because atoms are so small. So it's similar to a number like a dozen. So if you say you have a dozen apples, you know you have 12 apples. If we said we had a mole of apples, we would have 6.02 times 10 to the 23rd apples. So it's just a number that's equal to a quantity. In this case, that quantity we're calling the mole. The way that we most often use it in chemistry is 1 mole of a substance is equal to not only 6.02 times 10 to the 23rd atoms or molecules of that substance, but 1 mole of a substance is also equal to a substance's molar mass in grams from the periodic table. So you can see here that 1 mole of carbon has a mass of 12 grams, which is its average atomic mass from the periodic table. Okay, so let's look at a couple example problems here. So it says calculate the number of carbon atoms in 0.350 moles of C5H12O6. Now when we do this, this is a little different than what we did before. So this is actually asking for carbon atoms, whereas before we usually asked how many molecules were in a certain number of moles. So it'll be the same general process, but we're going to go through it just so you can see how it is just a little bit different. So 3.50 moles of C5H12O6. Okay, so that's our first substance we have to get rid of here. Now to get rid of moles, we know that 1 mole is equal to 6.02 times 10 to the 23rd molecules of C5H12O6. So that's equal to 1 mole. So that gets rid of our moles and it changes to molecules. Now, if all it asks for molecules, we'll be finished at this point, but we want to know how many carbon atoms. So now we're going to look at the particular formula for this substance, and we're going to say for every 1 molecule of that substance, there are 5 carbon atoms. And that comes from this number right here. So there's 5 carbons within that whole molecule. So just like before, you multiply across, divide top to bottom. So if we go ahead and do this calculation, we end up with 1.05 times 10 to the 24th carbon atoms. Okay, so next example here, maybe take a minute, stop it, try it on your own, and then come back and see if you got this correct. Okay, so my next one, I'm going to still start with the number they give me. So this time I have 2.5 grams of magnesium, and I want to know how many atoms are in that particular substance. Now, remember from before, you can't go straight from grams to atoms. You have to go through moles first. We talked about that mole bridge. And on the next slide here, we're going to look at how this all fits together. So remember, there is 1 mole of magnesium, and like we said in the last slide, that's equal to the molar mass from the periodic table. So if we look at magnesium on the periodic table, it has a mass of 24.31 grams. Okay, and again, that number comes from the periodic table. Okay, now that I'm in moles, so grams is gone here, now I can use my Avogadro's number to get 2 atoms. So 6.02 times 10 to the 23rd atoms. And then if I calculate that out, I get 6.2 times 10 to the 22nd atoms of Mg. Okay, and again, remembering we're still looking at sig figs here. So I rounded to 2 sig figs because my original number had 2 sig figs. Previous problem, I rounded to 3 because my original number had 3. Okay, so molar mass, if we remember again from before, molar mass is the mass in grams of 1 mole of a substance. So 1 mole of any substance is equal to either the mass of that substance, if it's an atom, or the molar mass, which is just the masses of everything added up. Okay, so let's do another example here. This one says, what is the mass in grams of 1 mole of glucose? Okay, so this is a fairly simple example here. All we're doing is to find the molar mass of 1 mole, we're just going to add those substances up. So you could just punch these into your calculator. If you want to do it a little more systematically, you can go through it this way. So each carbon is 12.01 each hydrogen is 1.01, each oxygen is 16. So if we add all of those up, we end up with 180 AMUs. And since we're doing the mass in grams, we could say 180 grams of C6H12O6 is equal to 1 mole of that substance. Okay, so if we're going to look at interconverting between these, this is our kind of map that we used before, and this is the model from your particular textbook that you have. So notice moles is in the middle. Okay, so that's like that mole bridge that we talked about to get from grams over to formula units. And the formula units could either be atoms, they could be particles, they could be molecules. Most likely we'll use the formula unit is either going to be atoms or molecules. So depending on what you're given, sometimes you might need to use multiple steps, sometimes that might just be a one-step deal. But to get from grams to moles, we're using the molar mass. And I'm going to go on to the next slide because I've got this graphic that we used before. Okay, so here's the interconverting. So moles is still in the middle here, so that's our bridge. So 1 mole of any substance is either equal to the 6.02 times 10 to the 23rd molecules or particles. Now notice this is reversed of what we did before, but this is the one we used back in Honors Chem, so that's why I pulled this back to try to help you remember what we did before. So 6.02 times 10 to the 23rd molecules, particles, you could also say atoms would fit over here if we're dealing with individual atoms. And then on the other side, 1 mole is equal to the molar mass in grams, and again, this comes from the periodic table. So atoms or molecules to moles to grams, and this can go either way, so we could put arrows on both sides of that. Okay, so let's look at a couple more example problems here. This one says, calculate the number of moles of glucose in 5.380 grams of that substance. Okay, so we have 5.380 grams of glucose, and from our previous problem, glucose was C6H12O6. You might remember that from biology. So C6H12O6. So we have that many grams of glucose. So if you remember from the slide we just had up there, we can go from grams to moles, straight from grams to moles using our molar mass. So 1 mole of glucose, C6H12O6, is equal to that 180 grams that we calculated on the previous example problem. So this is just the molar mass. So that 180, all we did was we just added up all the different elements in that compound. Okay, so this is it. So this is only a one-step deal because we were given grams and we were asked to go to moles. If it asked us to go to molecules, we'd have to take it one step further. So then again, multiply across, divide top to bottom. So we end up with 0.02989 moles of glucose. Again, keeping 4 sig figs here because we had 4 to start out with. So this is moles of C6H12O6. Okay, let's try a couple more examples here. If you want to try one of these on your own and stop for a second and then come back and check and see if it's correct, that would be great. Okay, so this one wants to know mass in grams of 0.433 moles of calcium nitrate. So now we're starting with 0.433 moles. Okay, calcium nitrate is CaNO3 2. And it's real important that you get the correct formula for these if it's not given because that's going to affect your molar mass. Moles is here, so moles goes on the bottom. So 1 mole of calcium nitrate, we need to calculate the molar mass of calcium nitrate. So we need to add up 3 oxygen plus 2 nitrogen plus 1 calcium. And that would be grams right here. And I do not have that written down, and I don't have a calculator right now, so I'm not going to stop all this, so I'll let you fill in that piece there. But then after that, I do have the answer for this written down. So multiply across, divide top to bottom. This again is the molar mass that you'll have to calculate, because like I said, I don't have that. And then our final answer here would be 71.1 grams of calcium nitrate. Okay, so again, moles goes on the bottom to cancel out. This is the molar mass in grams from the periodic table. You just add all those elements up, multiply across, divide top to bottom. That's where we get our 71.1 grams. Okay, our last example for this section. We need one more example. Now we want to know how many glucose molecules are in 5.23 grams of this substance. So this time we're going to go all the way across. So we have 5.23 grams of glucose, which again was C6H12O6. Before we can get to molecules, we have to go through moles. So 1 mole is equal to the molar mass in grams, which from before, if you remember, that was 180 grams from a couple example problems back. So this is still glucose, C6H12O6. And then our last step, since we need to go all the way to molecules, now we're going to use Avogadro's number. So 1 mole of glucose is 6.02 times 10 to the 23rd molecules. So if I do that calculation, I end up with 1.75 times 10 to the 22 molecules of glucose. Okay, and again, the path that we're following here is we can go from grams to moles using our molar mass, and then we can go from moles to molecules using Avogadro's number.